going to just explain to you about Energy House 2.0 project. The built environment accounts for 40% of the UK's carbon footprint. To achieve net zero will require a step change in the design of new buildings, but also, more importantly, it will require comprehensive upgrading retrofit programs to existing housing stock. The UK Green Building Council estimates that 80% of the 2050 building stock has already been built. At a cost of £16 million, the construction of Energy House 2.0 is being supported by the European Region Development Fund, ERDF, and the Office for Students. This is the building here, Energy House 2.0. The building commissioning of Energy House 2.0 was completed in February 2022 and is the largest research facility of its type. Within Energy House 2.0 there are two environmental chambers, each able to accommodate two detached houses, and under controlled conditions recreate a wide variety of weather conditions with temperatures ranging between -20 degrees C to +40 degrees C, and simulated wind, rain, snow and solar radiation. This unique facility will play a key role in accelerating the progress towards low carbon and net zero housing design, and builds upon the success of the original Energy House laboratory, which was opened in 2012. In June 2022, the next phase of work commenced. In partnership with Barratt Developments, Bellway Homes and St. Gobain, we started building test houses inside the environmental chambers. This will be followed by testing and research programs which will continue until spring 2023. This is some of the University of Salford staff who helped bring Energy House 2.0 to life inside Chamber 1. Be part of Energy House 2. With the ERDF support, the Energy House 2.0 academic and technical team are working with businesses in Greater Manchester to develop low-carbon technologies for buildings. The project build was completed in February 2022, and during March and April, 4 different types of houses will be built inside the environmental chambers that will act as test beds for low and zero carbon technology. For companies with suitable technologies, we're able to offer access to the Energy House 2.0 for testing and research entirely free of charge. If you would like to be involved, please contact us at energyhouse2@salford.ac.uk. A few other illustrations of Energy House 2.0. So we go to this article which I'd like to explain to you. This is one of the recent trials of house builder trials of roof-mounted heat pump. And you can see the heat pump in the photograph here, mounted on the roof. You can see the trimming got to be finished so that there's weatherproofing around the heat pump. Bellway is trialling the roof-mounted heat pump in its future house at the University of Salford. House builder Bellway has installed what it claims is the UK's first roof-mounted air source heat pump as part of a new trial. Bellway is testing the heat pump at its experimental eco-house, the future home at the University of Salford. It is hoping the trial will help to make it easier to install heat pumps, which usually sit adjacent external walls, taking up space as well as dominating the external appearance. Gas boilers are due to be phased out in new UK homes from 2025, and air source heat pumps are expected to gradually replace them. Bellway has engineered the eco-house to support 200 kilogram air source heat pump within the roof space. We will compare the unit's performance with a second fitted to an external wall. With a test for low carbon tech. Bellway is building the future home inside a climate control chamber at the university as part of its £16 million Energy House 2.0 research project. The project receives part of its funding from the European Regional Development Fund. The home will test low carbon technologies and their impact on the cost of living. And this is an illustration of the University of Salford's Energy House. We saw it in the other article. Other technologies include underfloor and infrared heating. The house will also test mechanical ventilation, double versus triple glazing, battery storage for solar energy, and a shower which transfers heat from wastewater to warm the incoming main supply. Bellway has worked with home heating manufacturer Worcester Bosch to prepare for the trial, with the company providing the Bosch 3400i Hydrotop solution unit. Donaldson's Timber Systems redesigned the home's timber frame to accommodate the unit. Bold move. James Bursnell, Group Technical and Innovations Manager for Bellway, said installing an air source heat pump within the loft space is a bold move, one that no UK developer or retrofit project has previously attempted. During the research period, we will have people living within the home to test the performance of the heat pump during real-life use. If the unit in the loft performs well, it could create a new way for homeowners to reduce their carbon footprint without compromising on space or aesthetics. It is well documented that air source heat pumps could increase running costs, but so far there is little reliable data on their performance. We are looking to find the optimum settings to maximize effectiveness and minimize cost for our customers. Professor Will Swan, Director of Energy House Labs at the University of Salford, added, "The growing challenges of climate change and the cost of living crisis mean we need to consider how we build and operate our homes. Energy House Labs' mission is to work with the industry and policymakers to provide evidence for what works in meeting these challenges. Energy-efficient, high-performing homes can change people's lives. The importance of this agenda is one of the main reasons behind the University of Salford's major investment in Energy House 2.0, which is a critical piece of research infrastructure that can help us find solutions to these problems. In the new year, guests will stay in the home to help generate data on the effectiveness of each innovation. Experts at the university will analyse the results to help determine the most viable ways for the industry to move towards net zero." So we look at the future home. Bellway builds the future home to test zero carbon reduction technology. Bellway has begun building an experimental eco-house called the Future Home as part of a research project which could influence how we use our homes in the future. Bellway's The Future Home is being built at the University of Salford's leading net zero research facility, Energy House 2.0, that has been part funded by the European Regional Development Fund. The house will test innovations in building materials, the effects of double and triple glazing, storing solar energy, recovering heat from wastewater, and how to make most efficient use of air source heat pumps. Each of these elements will be monitored in both regular and extreme temperatures, with varying weather conditions simulated inside the specially built chamber. In building this home, Bellway is taking a lead in the house building industry to test technologies to help meet net zero carbon targets. Jamie Bursnell, Group Technical and Innovations Manager for Bellway, said the results of this project have the potential to change how we build homes and how we live in them. In building this home, Bellway is taking the lead in the house building industry to test technologies to help meet net zero carbon targets. However, with many of these innovations, we don't yet know how they will function for real families and real homes, or what their running costs will be. This is particularly important when energy costs have risen so significantly and homeowners are being hit heavily in the pocket. Energy House 2.0 will enable us to find out how everyone can operate their homes more efficiently and how new technologies can assist our efforts in reducing carbon emissions by building more efficient homes. The research will produce reliable data that can help us all to make changes. We will compare the theoretical and real performance of different energy methods, finding out how our habits impact on energy consumption and retention. The house will be tested in temperatures as high as 40 degrees C and as low as minus 20 degrees C. Weather conditions, including wind, snow and solar radiation, will be created in the chamber. Bellway's Future Home is one of the first projects for Energy House 2.0, which is starting to develop into a hub to help industry address how our homes will need to perform in the future. Energy House 2.0 officially opens later this year and will be working alongside industry investigating how housing design can progress to enable the UK to achieve its net zero carbon emissions target. The research facility will contain 2 environmental chambers that will accommodate 4 houses and has the ability to replicate over 95% of the world's climatic conditions. Professor William Swan, Director of Energy House Labs, said Bellway's future home is one of the first projects for Energy House 2.0, which is starting to develop into a hub to help industry address how our homes will need to perform in the future. Over the next year, we will be undertaking globally leading research as the University of Salford and its partners start working on projects that solve issues ranging from cost of living and fuel poverty to living in future climates. Bellway started building its energy house last month, and the build program is scheduled to be completed by October. From then, data on energy efficiency will be collected and analysed by university experts. Partway through the analysis, Bellway's house will be retrofitted to upgrade elements of the building. This will include switching double-glazed windows to triple glazing and moving from radiators to underfloor heating. Sensors located around the house will measure the difference between the energy it generates and the energy it loses in different climates. They will also gauge the comfort of the house, which will be further explored by guests invited to stay there during the project, including University of Salford students. Jamie added, many of the technologies we will be testing are due to be in common use in new homes by 2026. This project provides us with the opportunity to test their effectiveness and to create solutions for any challenges we may encounter. The results will help us to deliver more energy efficient homes and to advise people on how to make best use of new technology to control energy usage and running costs. Dr. Richard Fitton, research lead at Energy House Labs, added, the modern house is by its very nature complex with novel materials, renewable heating systems and interactions between all manner of smart home infrastructure. Our research will help to present data on how all this can work together to deliver homes that are efficient, comfortable and healthy. The Energy House 2.0 project is supported by funding from the European Regional Development Fund and the Office for Students. Businesses across Greater Manchester are being invited to get involved in the project, and Bellway is among those who has signed up to the Friends of Energy House 2.0 initiative. Bellway is working closely with its suppliers and subcontractors on the project as their insight into the practical installation of new technologies will help to shape the specification of their future homes. Energy House 2.0 is one of a series of test sites Bellway has set up across the country to work with new energy-efficient technologies. Currently, 4 future homes are being built in Callerton, Northumberland, which will be available for open sale, and homeowners will work with Bellway to monitor energy usage as part of Bellway's wider carbon reduction strategy. Putting people and the planet first. If you've got any queries about this or any other projects or developments, then call Alan on 07539 141257 or 0333 224 1257. You can schedule a call with me at calendly.com/AlanJE, or you can drop me an email at alan@alpusgroup.com. That's all for now.